In this video, we will show you how to calculate the chi-square statistic. The chi-square statistic is used to look at relationship between two categorical variables. We're going to use a couple of examples to demonstrate the calculations. So the first example we have is a data set that is here. We have three variables: merit indicator, type of position, performance rating. The type of position and performance rating variables are both categorical. So in order for us to look at the possible relationship between these two variables, we use the technique called chi-square statistic. The first step in performing the chi-square statistic is to construct what we call a two-way table or contingency table, or cost tabulation or cost tab. All those names correspond to the same thing. To generate the table, what we need to do is to use the Excel's pivot table facility. In the table, we would be able then to look at the observed frequency, which is the frequencies of the various category combinations between these two categorical variables. Based on the observed frequency, then we will be able to use this formula to calculate the expected frequency. And once the expected frequency is calculated, then we can calculate the chi-square statistics in an organized way by breaking down the formula into various pieces. So let's get to it. So the first step, as I said, to obtain the observed frequency is to get to the contingency table or the two-way table. To do that, we use Excel's pivot table facilities. We would put our cursor inside the data set, and we would go insert pivot table, and we say OK here. And on the right hand side, you can see that the variables in the data set are listed here. And what we're interested in are the two categorical variables: type of position and performance rating. It does not matter which one would be the rows of the table, which one would be the columns of the table. So for us, we would just take the type of position and put it under the rows in this pane. And then we can also put performance rating under the column here. And we can now drag type of position or performance rating under the value pane. And you can actually see that we now have the pivot table generated. The pivot table actually is in the format of a contingency table. And what we have to do is then copy this into an area that we can work with. And I have actually done that here to make it a little bit easier. Right? So I just basically take this table and copy it over here and make it look a little bit nicer, right? And I'm going to put the heading observed frequency on top of it. So what it means here is that in the data set, there are three people who the position is management and the performance exceed expectation. There are 23 people in the data set that is classified as management, and the performance rating is fully meet expectation, and so on. So now that we have the observed frequency, what we need to do is to calculate the expected frequency. Now, in order for us to do that, what we can do is we can just copy the whole table here, down here, and I'm going to just change the observed frequency into expected frequency. Right. Now, obviously, the data, because when I copy it, if you can actually see it, we are actually linked to this pivot table, right? So when I copy this down, these numbers now is not no longer valid. So I'm going to blank this out, and I'm going to also blank this out, and we're going to calculate the expected frequency from stretch. Now, the expected frequency formula says the expected frequency of a cell equal to the row total times the column total divided by the grand total. This number is called the grand total, right? So this is actually, if I want to, this is actually the row total. And this is actually the column total, right? So the only problem with the pivot table is that the names are a little bit confusing, but now we can see, right? So the column total, basically the total of the columns, 3 plus 9 equals 12, right? 77, 11, and so on. And the row total are basically the sum of the rows, okay? And either the sum of the row total or the sum of the column total equal to the grand total. The grand total is the sample size. So in order for us to calculate expected frequency, all we have to do is to enter the formula here. Now, you can either actually do that by doing it individually. So for the management and exceed cells, we can actually calculate the expected frequency as 12 times 30 divided by 100. So you can actually either enter 12 times 30 divided by 100, right? And then you can actually go through the other calculation. Or if you want to use Excel formula to speed up the process, you can actually use this formula, right? We say H7. Now, X7 is the column total, right? So if I actually use the dollar sign here, that means that I don't want to change this column, times dollar sign K5, right? K5 is the corresponding row total, right? And I put the dollar sign in front, that means for this particular cell, I don't want to change the rows. And then I put in dollar sign K dollar sign 7. That means that in all the calculation, this number will be fixed. So why would I do all that? Because once I enter the formula, I can now not only calculate the expected frequency for this cell, I can actually just copy this over to all the cells, and voila, right? So if I want to check to make sure that I'm doing it right, I can actually put my cursor key in one of the cell and check, right? So column total times the row total divided by the grand total. Now this, if you don't understand Excel formula well, what you can do is to refer to the Excel worksheet I also provide in the link below, right? So if you look at the link under the description of this video, you can actually download this Excel worksheet, and you can actually just use this formula, as you know. Now, so now that we calculate expected frequency, we can add up the columns and we add up the rows as well. Let me just change this to make sure that we are not confused. Even though the expected frequency and the observed frequency are not the same, as you can see, the column total and the row total should remain the same. So this is one check that we can actually use. So we actually, if we do H12 plus H13, you should get 12, right? So let me just copy this over, right? And you can see that the expected frequencies are different from the observed frequency, but the row total and the column total should be the same, okay? On the other hand, I'm going to do sum of H12 to J12 to sum the rows, and the rows, of course, is the same as well. So I can actually just copy this down. And now that we have all the expected frequencies, right? So the observed expected frequency is the frequency of a cell. That's what we expect to see if there's no relationship between the two variables. So if there's no relationship, this is what we expect to see in management exceed performance. This is the frequency that we expect to see if there's no relationship between types of positions and performance improvement, performance rating. Okay, so now that we calculate expected frequency, the next step is then for us to calculate the chi-square statistics. So the chi-square statistics is a very complex calculation, right? So you take the observed minus expected, and then you square that number, divide by the expected, and then you sum over all cells. So in order for us to do this complex calculation, it is best for us to organize it into a table format, right? So in this table, we have all the cells listed: management exceed, management fully meets, management need improvement, and then technical, and so on, right? And then you have the various columns that correspond to the formula: observed, expected, observed minus expected, observed minus expected square, observed minus expected square divided by expected. So what we have to do is that we have to just copy this over, right? So we're going to just copy this over. And what we have to do is to copy, and because now we change direction, we just say transpose, right? So here we go. And then the second row, same thing, right? So we copy this over. Oops. And this transpose, right? So that's okay, right? So notice that we actually have, say, a typo here. Okay, so now that we have the, sorry, this is actually the expected, right? So we put it into the wrong column, and we should actually put it in the right column. So we actually should do the same thing for observe. So take this number, copy this over. Again, paste special, and it's transpose. And we probably should just paste the value as well. So we don't have to have a problem with the formula. Same thing here. Again, paste, special, value, transpose. Okay? So now that we have everything lined up, what we have to do is to do the calculation. Right? So the calculation is very simple. The first step is to calculate observed minus expected. So it's W5 minus X5, right? And then once you calculate the observed minus expected, notice that this number is negative, so we square it. So how do we square that? Y5 square, right? And then the last step, of course, is you take this number divided by expected. So is Z5 divided by X5, right? And so that would be one of the components in the chi-square statistics. And if you want, you should actually have 3 decimal places so to maintain accuracy. So now that we have done one for the first cell, we can actually just copy this over to the rest, right? And so if you want to check to make sure, right? So for this particular cell, technical exceeds, this is observed minus expected square, and then observed minus expected divided by expected. So that looks fine. The chi-square statistics then is the sum. So this is the notation. This is about adding them all up, right? So what we have to do is that we just say sum AA5 to AA10, right? And that looks good, right? And so finally, we calculate the chi-square statistic, and this is the chi-square statistics for the contingency table that we have created. Now, if we use the critical value approach in hypothesis testing, then you can calculate the degree of freedom, and then you can find the critical value from the chi-square table. Another way of doing it is this. If you are using the p-value approach, what you can do actually is use Excel function to calculate the p-value. So the way to do it is say equal CHI, and if you type in CH, you can actually now see that all the functions starting with CH, and one of the function is CHI SQ dot TEST. Right, so if you enter that, now if you look at this function says that you have to put in the actual range and the expected range. The actual range is the observed frequency, so it's x3, so x5 to J6, right? So this is the observed frequencies. And then the expected frequency is x12 to J13, right? So this is the expected frequency. And if you actually enter this, what this function would give you is the p-value that corresponds to the chi-square test. So in this case, you can actually see that this is the probability. Now, if you look at this function, this is one adjustment that you probably have to make. If you look at this function is a variable for compatibility and so on. Return the test to independence. The value from the chi-square distribution for the statistics and the appropriate degree of freedom, right? So this is the p-value for that correspond to the test. So as you can see that the p-values is so large, the hypothesis, the null hypothesis would not be rejected. Now, intuitively, if you look at this number, 3 and 3.6, 23 and 23.1, so what we observe and what we expect to observe or what we expect to see if there's no relationship is very, very close. So in this case, the null hypothesis that there's no relationship is not going to be rejected. So this is how you calculate the chi-square statistics if you are using the critical value approach and using the chi-square table, or if you want to use the p-value approach, you can actually do these tests in order to find the p-value. In both cases, you need to find the expected frequency. Now, I would like to, before I let you go, I'm going to show you how to analyze relationship between a categorical variable and a numerical variable. There are various statistical techniques that you can use to analyze the relationship between a categorical variable and a numerical variable. One of the ways of doing it is to convert the numerical variable into categorical. So you have two categorical variables. So in this example, we have two variables. One is called home ownership, which is categorical, and we have account balance, which is numerical variable. So how do I analyze the relationship between home ownership and account balance? Well, what we can do is to change the account balance into categorical variable. And to do that, we have to create a new variable, and I'm going to call the new variable balance range. Now, in order for us to create that new variable, we would like to know how these numerical variables are being categorized. I'm not going to show you the detail. If you look at the detail of this variable, you can see that most of the account balances is between $0 to $30,000. So I'm going to break it into this variable into three categories, right? One is from 0, and then 0 to 10,000, and then 10,000 to 30,000, and then over 30,000. So these are the breaks between the balances, and I'm going to break them into the balance range. So in order for to do that, we're going to just type in 0 to 10,000, 10,000, 10,000 to 30,000, and over 30,000. Okay, so you can either go through the account balance variable and do it manually. For example, the first one you say, oh, this one is between 10 to 30, 10 to 30. This is 0 to 10, 0 to 10, 10 to 30, and so on. You can either go through it manually, or you can actually use Excel's lookup facility. So I'm going to show you that, right? So in order for us to do the lookup, what we first need to do is to define this into a range, a name range. So to do that, we go to Formula, and we go to Define Name. So we're going to define, give it a name for this range. And I'm going to call this a BR, right? Balance range. And balance range has this area, right? So it's in this worksheet. It's from I11 to J13, okay? So I define, I give this region a name, then I can refer to it. So once I've done that, then now I can actually use Excel's VLOOKUP function, right? So to do that, we say equal sign VLOOKUP. Okay, and what are we looking up? We're looking up account balance. So this is D2. And where do we look up this value? We're going to use this table, and this table is being referred to as BR. And the value that we're going to create is the second column once you look at this range. So we put a 2 here. So take this value, use the first column to look up the categories, and the name of the lookup is in the second column. So this is 2, and the last one you have to put in is 2. Okay, so this is the VLOOKUP syntax, right? So this is what way you're looking up, the name or the lookup range, the second column in the lookup range, and 2. That means that you don't have to be exact when you do the lookup. And if you enter that, then you can see that the first one is being categorized between 10K to 30K. And once this is done and is properly done, what you have to do is just copy this formula to the rest of your data set, right? And bingo. So this is actually really easy to do. And once we create this categorical variable, then we can now analyze the relationship between home ownership and balance range by going through exactly the same process. So for example, we can actually do insert, pivot table, and say, okay. And now we can look at home ownership as rows, balance range as column, and we do the count on the balance range. And here we go. So here is the contingency table, or the two-way table for these two categorical variables. One is called home ownership, the other one is called balance range. And everything that we have done can now be applied to this particular situation. So to summarize, what we need to do in calculating chi-square statistics in Excel is by and large menu, and the best way of doing that is to organize ourselves when we calculate the chi-square statistics by first calculating the expected frequency, and then after the expected frequency is calculated, you can organize the calculation of chi-square in a table like this. So thank you for your attention. We'll see you next time.